My name is Marcel. I am a entrepreneur at the moment here, being located in Berlin, Germany, and I have been working in AI since 2014. That's given that AI has been around for, I think, Term was the first time being mentioned in a paper in 1953. So it's a 70-year-old concept that had different levels of renaissances and hype cycles behind them. I was joining the AI hype train in 2014. It was by the time that a few researchers from Stanford figured out how to use graphics cards, GPUs, to compute and evaluate neural networks, train and evaluate neural networks in a much more efficient way than it has been before, because neural networks have been around for quite some time. So that was the time, that's now over 10 years ago, that I got into AI. And more recently, in the past couple of years, especially the last 3 years, with that whole ChatGPT hype that brought a whole new different class of AI, meaning generative AI, large language models, and very, very complex models that are able to create content to more or less reason. That's a debatable topic. Do these models actually reason or not? Well, it's statistical models that do something that looks like reasoning. Is that really reasoning? Who knows? That's not a battle that I can fight today. But that's the type of stuff that I deal with in my daily life. I have only the last 3 years implemented about 3 dozen generative AI projects with companies, startups, but also multinationals with 300,000 plus people, where I build AI projects together with my team for them or help them build on their own. I'm also the founder of a platform called EndEngine, which is basically a no-code AI tool that you can use to build AI-powered applications end to end. Specifically, you can build 4 different types of application, and these are the 4 different types of applications that I'm going to tell you a little bit about today. But before we get started, I would like to show you this picture here, and I would like to encourage you to put any type of questions that you have while I'm sitting here staring into the infinite abyss of the internet. Put it in feel free to put it at any point in the meeting chat that you see in Zoom. If you see me lurking towards my left, then it's for the reason that I'm checking if there are any questions. And if there are no questions, I would just continue my normal flow and go through the rest of the questions in the end. Feel free to do so. This webinar today is also recorded. So if you have to buy any occurrence leave for any reason, don't worry. We are going to send you all an email afterwards with the recording of today's webinar. And with that, I would like to show you this picture that you have already seen here as a spoiler, and you probably have already stared at it intensely. This is ChatGPT. You probably all have seen that by now, and you see how it works. It's basically an interactive interface where someone is sitting in front of a chat box and is conversing with some sort of intelligence that is not a human, but in the same way like you would do it with a human, because that's how we human works, right? We have discussions, we talk back and forth, and usually a conversation is structured in a way that one party says something, then another party says something, taking into account what the former party says, and going back and forth. That is basically how and why this hype around ChatGPT started in late 2022, I believe, late 2022, because it is an interface that is that simple. Anyone who has ever used Facebook Messenger, WhatsApp, Telegram, whatever, or even wrote SMS in the 1994, anyone who has ever done either of those things knows how to use this interface and get something out of ChatGPT. I have other webinars where I tell why ChatGPT sometimes hallucinates, sometimes doesn't give you the quality that you want or the reproducibility that you want. But these are all topics that we're not that we're only touching on today and not focusing exclusively on today. But the core thing is an engine, the ChatGPT is an interface that's interactive and that lets you do something with it. But when we talk now about a company that wants to use AI for making their business better, we talk about the question of how can I have a certain business process that I have right now and that people or other systems are executing right now. For example, customer support, but also other things like I need to write reports or write appraisals for whatever, create documents, analyze documents that I've been given. These are all use cases that a generative AI in a large language model, a decently powerful large language model like GPT-4o or 1 or a similar one can do, but that are in the operations of a company not necessarily the best to be in a chat interface. And chatbots are really, really great when we have creative tasks that need interaction in processes that are always different. So give me ideas about how to do this and this and that. Structure this part of the presentation a little bit different for me. Write a paragraph on XYZ. All of these tasks that you do usually once, or if you are not happy with the output, twice or three times, but where you don't have thousands of repetitions of the same thing that you are trying to achieve, then it is the place where chatbot is great. But when we look now into a different use case, you can, for example, with a large language model, you could do typical operational tasks and also operational financial operations, like here it's invoice controlling. Of course, you can go to ChatGPT, upload an invoice and say, hey, this is my invoice, is the amount $1,249. And ChatGPT is doing analyzing it. So you sit there and write a little bit and says, yes, it is. And then you ask, which cost center can I map it to? And then it asks you, what cost centers do you have? And then you give a list and you converse with that system like you would converse with an intern, with a smart intern who can get stuff out. But the thing is, if you have 120 different invoices, you don't want to have 120 different conversations about each of these invoices, because the time that you spend, let's say one task is giving you an hour, is taking you an hour to do to do it manually. Yeah, one-time task with no AI. Let's say this is 1 hour. When you do the same task with different parameters 4 different times, then you need 4 times 1 hour. But do you now, in an interactive way, interact with a chat interface like ChatGPT, then you have, let's say you save 50% of your time, which would be a tremendous improvement. But let's look into what we actually save and what we spend our time with. We spend our time, a little bit of our time with writing the prompts. We spend a little bit of time in between the prompts to wait for the result. And we spend some time on quality issues, errors, adjustments, yeah? Like you have seen here, right? Cost centers. Of course, it didn't know the cost centers. So I have to go there and I have to supply cost centers and provide that to the model. That's all of that time in one of these blue boxes over here. And if you do the same task 4 times, you have 4 times saved 50%, but you always have to 4 times do these things, because reproducibility is not the easiest thing to do with large language models. So you have to do a lot of prompt tweaking until you get there. So question is this really as good as we get? Or also the question on that, do we need to force everything into a chat interface? These time savings that we have here, 50%, but then still 4 times waiting, quality, errors, adjustments, and writing the first prompt. That's the repetitive task that you always have, but that you should always get a consistent result in a consistent way that you get. But we can do much better by basically getting rid of everything but that small little blue thing over here, by working with what we call a process template. And with the second thing, more efficient interfaces. So business processes have been around since we have business. But this whole, let's say, large language model craziness that has gone around led to a lot of people just using it as a dumb tool for the things that they do once and here, once and there. But the thing, what you really have, or what where you really have an opportunity to get over the first initial barrier, where you then see a certain level of resistance, and you can get much more validation is, or quality out there is if you analyze your processes that you have. For example, in my invoice controlling, look, so first I am uploading my invoice, then I am extracting all invoice items, then I am mapping these invoice items to a cost center, and then I'm looking if in this cost center this was budgeted or not. That would be the way of how you break down this process into a sequence of different steps. And if we build now a template that uses a large language model, for example, and we tweak the prompts in a way that we only need to change out the variables that are changing over time, for example, the invoice document itself, but leave everything else the same like it is in the template, then we have something that we can scale. You need to think there about data that you have per case. So a case is basically one instance of a process. I have one process that is called invoice control. And then I have one instance of this process. One is called, that case is called invoice controlling for invoice number 170 for my pencil supplier. The other case is invoice controlling for invoice number 244 for my kitchen supplies. And then you have a third case for a third invoice for number 452 for your cloud costs or so. These are all different cases, and you have data that you share between cases, and then you have cases, you have data that is specific for that case. And that's what we call the differentiation between case independent and case specific data. When you think about that, you can build and create yourself these process templates and only swap out the case independent, the case specific data, and reuse basically the same battle tested prompt and template that you had before in a much more efficient way. Then we need to talk about interfaces, because that interaction interface from I do step one, I prompt it to ChatGPT, I take it, I look at it, and then I see if I need to adjust, and then I start step two. That takes time. And it's not the most efficient interfaces for stuff that is reproducible, that is always the same, that is always repetitive in the way, in terms of the steps that we are using. And this, if we are thinking about these different parts and we bring them together, we get a much bigger improvement of quality and of efficiency, because we eliminated a big portion of the human error if we do that consistently. So that's a switch in the mindset. We need to go away from building AI, from doing a chat, to building AI-powered applications that have basically templates for processes with AI and make it faster. And in that way, we can get a much bigger time and efficiency gain, because not only the 50% that we have by the AI is faster, but also by saving up all of the quality and error adjustment time that we only have to do once while we build it, but not during runtime. And that's exactly how we create enterprise-generated AI with actual impact. Yes, chat interfaces are fine for many things, but if you're only looking for the things where chat interfaces actually make sense, it's only a part of what the underlying technology, generative AI, can actually do for you. Now, let's talk a little bit about how we can implement these type of AI-powered applications architecturally. When you think about using ChatGPT as one application, but if you use a large language model as a part of an AI-powered application in enterprise, there's much more layers to that. We have on the bottom, we have the hardware layer. course, these models have been trained at before runtime, and they have to get evaluated during runtime. And they need quite beefy hardware, to be frank with you. That's why you see all of the NVIDIAs of this world making a lot of money, creating very good and very specialized cards that are good at evaluating large language models and neural networks in general. And that's the hardware part of it. Then you need, of course, a model part of it. And you have several options how to get that. You can get an AI from an AI model, a large language model from a model provider as a service. For example, the OpenAI API is one of these services where you can just say, hey, I would like to have, I'm buying in tokens from you, and I would like to use them to do some AI large language model evaluation. You have the possibility to use open source pre-trained models, for example, Llama in your own infrastructure or somewhere else, or you can build your own model from scratch. These are the three different options that you have for models right now. As long as you are not a Google, an OpenAI, or somebody else, I wouldn't recommend you building an own model from scratch just because it's very expensive and it requires a lot of knowledge. If you're not a specialized company in that, I would rather discourage from doing so, maybe apart from a few edge cases. If you have an own model that you don't take as a service by an API, you have to think about tools and model operations that you need to do, and you need to do cost monitoring because that's not so easy to see always how much one instance of this process costs you. You can do fine-tuning to get some additional information into a large language model that has not been in the initial training set of it, but that's something that I these days also disencourage because there's a much better pattern to work with actual data without having to retrain the model, and that pattern is happening on the next layer, on the orchestration and on the data level. We in an enterprise, we are usually not, let's say, we are not completely satisfied with only working with data that is there available in public models that everybody else in the world has. Large language models like GPT-4, GPT-4o, have been trained on the combined wisdom of the Western world. General knowledge and different disciplines, but these models do not have the knowledge that is within your company, because that's usually knowledge that is not publicly available, right? Your internal earnings reports, your OKR reports, they are not part of the combined wisdom of the Western world. They are only part of the very specific information and knowledge base within your company. And making this information retrievable and usable within an application that uses a large language model, that's what really makes the impact in enterprise. And we do that, for example, with a pattern called retrieval augmented generation, where we are using a vector database to do semantic search and find relevant context data for a certain query that you have and that you put then afterwards into a large language model. And that part of the interface towards the application, I'm taking over use case specific input. I'm looking up information via semantic search at vector databases in my knowledge base, and I am putting large language models to work, and I put that all together in a series of different steps. That's what we call orchestration. And if you ask me, at the moment, the most value that you can get here is not by always having the best model for everything. Yeah, there is the pricing difference between GPT-4o mini and GPT-o1, the normal one, is a factor of 1,000. So keep that in mind. You cannot always use for everything the best model, but there's a lot of manipulation that you can do here on the orchestration layer to get good and reproducible results. And that's exactly the architecture that I recommend as the enterprise reference. And on this level, when we talk then about the application, the orchestration layer, that's where we have our 4 different types of applications that come. Number one, I will talk a little bit, and you will see in the background use cases, or let's say screenshots, screen recordings from the End Engine software. That's a software platform that I built together with my team to build these 4 different types of applications with a no-code interface very, very quickly, scale them very quickly without having to sit there for weeks to code. And what you see here is just an AI process automation that you take and that you embed in your existing systems. So you see here, this is our invoice recording or our invoice controlling case. Our first step that we are programming, or with no-code programming here right now, is a 2-step process. The first step is getting all of the items from my invoice, extracting it with a large language model, and then mapping it in the second step to the cost center. That's a 2-step process where we defined 2 steps here in this overview, and that we can orchestrate then afterwards with every new case that we have in the same way. And you see here, this is where we put in our case independent data, so our case dependent data, the invoice and the cost center that changes always from case to case. Then we have, of course, the chat application. I don't need to tell you too much about how chat applications work. You know exactly what that looks like because you have been using ChatGPT probably excessively. That is the interactive way, and we talked already a lot about that today. Then we have knowledge search applications. Knowledge search applications use and traverse existing knowledge sources. For example, a knowledge base that you have about your internal procedures or frequently asked question things in a very complex way. And these processes on retrieval can get quite, let's say, quite advanced, depending on how much time you are willing to put into building these workflows and how complex the task of finding the right information is. So we are generally talking about a retrieval rewriter structure that basically takes a query that you have. For example, can you give me the data that we made in revenue in EMEA in 2022 in Q4? Then we are putting this information into what we call a query rewriting step. That you have also seen here in this process definition. The first thing is the query rewriting, where we say, okay, what are the interesting words and concepts that the user might not have asked in this question, but are relevant to this? What are the right words and the right concepts? That's query rewriting. Then we do the retrieval with our retrieval augmented generation. And then we do in the post-processing, we not only get the one top answer, but we get the top 5, 10, 20 answers, and then do again a re-ranking of these answers depending on how good they are. And that's generally, if you can put it in something like a search, like Google, what we call a knowledge search application. And the nice thing about using retrieval augmented generation is that you can see and work with the exact sources that you have in your knowledge base. You don't get anything like in ChatGPT where there's something hallucinated together and you don't know where that information is coming from and you can't validate it. But with this approach, you can. And the last type of application that I have seen across the 3 dozen applications that I've built with my team in the last 2.5 years is what I call an editor application. Because often people want to use a large language model to create some sort of document, a report, or here for you see that we are automatically creating a contract. In legal, there's a lot of use cases for this type of application. And in the end, this is also an interactive, but also a non-interactive to some extent way where you do it. So let's say you are a real estate company and you're writing real estate appraisals. You're going out to 1,000 different objects a year and say, okay, this is an apartment with 4 bedrooms and it is in condition X, Y, Z. That document is always structured in the same way. And you always have, for each of these 1,000 different apartments that you want to do an appraisal for. So you have, for every thing, that's where the term comes again, a template that you want to fill out. But you don't have a static template, but think about a template where you fill in each of the different sections of this template with an AI task. And that's exactly what you see here on this view of what we call an editor application. You have on the left side, you have your working document, and on the right side, you have predefined AI tasks, which are process templates, where you fill in the variables from your current case, and where you generate the exact part that you need to copy and paste in that section. And that's what we call editor templates. And these 4 applications basically cover, so far what I have seen, 95% of all large language model-based generative AI text use cases in enterprise. And many of the people who get into that space, they are stuck here, and they are trying to force everything to be a chat application, or the new term, an agent. There's parts where you need agents, there's parts where you need chat applications. There's also parts where you need to work in some interface like those 3 with reusable processes. They're not either or, but they're complementary to each other. And the types of use cases, depending on what you want to achieve, fit better to either one option or the other option. And that's the core message that I want to tell you today. Think about what these large language models can do. They can do and process text in a way, if you give them the right prompts, that is very powerful to you. But a lot of the efficiency for repetitive processes goes away when you have to have someone sitting in front of a chat interface and always doing mundane work. If you go steps further and you think about other types of applications, then you come to a point where you see on an operational level much more efficiency improvements. So, and that's the 4 types of generative AI applications. What I would like to show you now next is how usually these enterprise-grade generative AI applications start and how they evolve. So in the beginning, there's always from some sort of decision maker, the decision, yes, AI is now our focus and we do stuff with AI now. Very colorful speaking. Then what I have seen in so many companies, usually these people do not have the problem that they don't have ideas on what they would like to use with AI. So there's usually more idea and potential use cases that are actually viable. And in the first step, what you as an organization have to do, you have to analyze the potential impact of these use cases and make a decision on where to start with a proof of concept. I do workshops for that, and I also have a template where you put in basically the time you need for certain tasks in your process, and then you can type in what you expect the efficiency gains to be, and it calculates the amount of money that you in the end save. If that's something where you need a little bit of help to show return on investment to a board of stakeholders, feel free to shoot me a message. I'm more than happy to help you up there. But the point is, there's always some sort of decision maker or other stakeholders that in the end make the decision on which of these use cases to pursue. And then these use cases go into the feasibility validation. And that's usually where we need to make the decision for a feasibility study for proof of concept. Which of these 4 types fits that application best? Well, because I actually do not recommend building a user interface directly from the beginning. Use whatever you can get out of the box by existing tools, like the platform that I'm going to show you in a second, to do these proof of concepts and validate if the content that comes out is good. User experience challenges is always the second part. That's the secondary to it. The question that you want to answer in the proof of concept is the quality of what you get good enough, and how big is the impact in the process. And then you evaluate that and decide to go live only with a selection of those things that you have sent out after you validated what the return is and what the actual savings are. And that's really a process-related mindset. Yeah, you can also say, yeah, I'm just doing chats and maybe here a customer support chat and here and there. But the real bang for this application is happening when you talk about your repetitive internal processes, hard to automate back office tasks that at the moment highly qualified people are doing for a relatively low qualified work. Yeah, stuff like writing a report. Yeah, anyone can in the end write a report. You just need someone who is specifically knowledgeable about a certain area to write a good report for a given purpose. But it's not that this is a skill. Everyone has the skill of writing who's working in a larger scale enterprise, almost of the people at least. It's a question of how to combine information, data, and knowledge into something that you can reproduce and roll out. And I have seen a lot of pitfalls that I just want to tell you in this process. So if you have 50 use cases, don't build 50-point solutions. Have one platform where all of your generative AI applications live that you can scale. Don't sit there manually doing code. Yeah. There is so many tools for the proof of concept phase where you can try out things without having to employ a whole team of 12 developers to do something basic. Yeah, if your proof of concept is so big that you cannot do it even with the tools out there without having a 12 people team, I would recommend you basically putting it into smaller projects and then dividing and conquering it. When you're in a proof of concept phase, do not be in isolation for too long. Validate what you have built from idea to prioritization and to production in the end, so that you have a continuous feedback loop and not just someone who's sitting there for half a year and they're doing something with AI in the end nobody is using it. Trust me, I've seen that so many different times. You can't imagine it. Don't tell your people to here's AI and now go figure it out. Yeah, it's ChatGPT, it's easy, everybody can put right into. No, give a concrete objectives, give clear goal statements, and let them try it out within defined goals. And also give the education and the other tools that go over only a chat interface to be there. Not every solution is unique. They all have the same, or many of them have the same components, at least that they share. So if you go to this topic by basically mapping all of your applications to these 4 different types of generative AI applications, you have already solved a lot. Think about scaling costs right from the beginning, because these generative AI models are often usage-based. So if you have something that in the end costs you per call 10 cents, and you say, it's 10 cents, it's not a lot, but you have it 10,000 times that you're executing the same thing, that becomes step by step, or 100,000 times, that becomes considerable cost. If you have these type of very highly repetitive processes, it makes a lot of sense to already optimize your token usage, your credit usage right from the beginning and optimize along the way, than saying, oh, that's something that we do later. And the 2 last things is, don't only focus on the models as the key variable to the quality. Focus on the orchestration, because even with a mediocre model, you can build very, very impactful applications if you orchestrate them correctly. And try to quantitatively evaluate your outputs as early as you can, than just with one person doing it one time and saying, yeah, it's good. These are statistical models, so there is, no matter how good of templating and engineering we put into, there's always a certain margin of error and of variance that you have to do. Talking about variance in the sense of Six Sigma variance, of course, you always, for good processes, you always want to reduce variance as much as you can. And control it as far as you can. And by having a larger test set, that's already out of the box. I said it before, if you want to do more than one application, don't look for point solutions, but build either get your own in-house platform or get a platform from an external solution provider, either completely as a SaaS or also on-premise. It's basically what my daily business is. I developed with my team the Engine platform that lets you build these 4 different types of user interfaces and all of the processes behind them with this no-code drag and drop feature that you have seen. That in the at the moment can solve basically any generative AI use case in maybe a quarter of the time that you need, and when you would sit there and program things manually. We have connections to different models, proprietary or open source, for different modes, for text, for image, for voice. We can deploy that whole platform on premise or in the cloud. We have fine tuning and retrieval augmented generation with no code. We have the app builder, and we have also the possibility to integrate your corporate organizational structure and governance tool. And if that is something where you are at the moment struggling with, we are building proof of concept, but we are also building things that directly from a proof of concept after a short go live session go in production, so that you don't have this. We have now a playground, and we throw away the playground, and then we need to rebuild again. If you want to do that by yourselves, we can teach you and we can help you. If you wanted to us to build it for you, we are also more than happy to do that. If you would like to book a meeting with me, there is my link to my Calendly, I believe. And with that, I'm at the end of this presentation, and I hope that you have got some information, learned something out of it, and I'm more than happy to answer any other questions that may or may not be out there.